All right. While Deanna gets settled in here, I just want to say welcome to everyone. Welcome back, I guess, after our week off last week.
Richard, can
Yes.
you hear me? Okay.
Yes. Yes. So I just want to again remind everybody of the workshop that we are hosting on October 21st. So I've had a fairly good response thus far as people at least accepting the calendar invite. But for those planning to actually attend the event, remember that registration is required. And there is a link in that calendar invite email. Deanna, are you ready?
Yeah.
Okay, so today we will be having Deanna Salguero.
There
Is that
you
close?
go. Yeah, perfect.
Okay. Presenting on her work looking at sulfur fertilizer in corn within the state of Indiana. And so, Deanna, with that, I'll go ahead and turn it over to you. You should be good to share your screen and everything. So.
All right. Thank you. Okay, there we go. Okay. Well, thank you for joining me this afternoon. This afternoon, I am going to share with you the work we have been doing, as Richard said, by looking at corn yield response to applications of sulfur throughout the state of Indiana. So sulfur is the main constituent of two amino acids in the plant, methionine and cysteine, who are important to build up crops. So a tool utilized as a diagnostic criteria of sulfur in the plant is by looking at nitrogen to sulfur ratio. And the value reported in the literature as a threshold is an 18:1 nitrogen to sulfur ratio in the plant. And when we just look at sulfur in tissue, a threshold reported for that in the literature once again is 2.1 grams of sulfur per kilogram. So now, how does it look like sulfur deficiency in the plant? So here I have a picture where we have, this picture is from one of the fields we had last year. So in the foreground corn, we did not apply sulfur. And in the background corn that looks like with a greener color, we did apply sulfur. So the sulfur deficiency symptom looks like, as you see, a pale yellow color. Sometimes we might see some striping as showing this smaller picture. So that is a way that we can identify sulfur deficiency in the field by looking at the plant. Now, in the past, we wouldn't see much responses to sulfur fertilizer in many crops, but there is a perceived increased incidence of sulfur deficiency in the Midwest in the past years. So here I have a map to explain the main reason that is associated with these changes in sulfur availability for plants. So in this map, we are comparing 2018, where the atmospheric deposition of sulfur is much less compared to 2000. So for the state of Indiana, the atmospheric sulfur deposition in 2000 averaged 20 kilograms of sulfur per hectare for that year, compared to 2018, where that deposition dropped down to 6 kilograms of sulfur per hectare for that year. So another factor associated with a reduction of sulfur availability for plants in the soil is the adoption of reduced tillage, because this practice might reduce the rate of mineralization of the organic matter, and the organic matter can be of a significant source of sulfur for the plant. The critical level of sulfate sulfur in the soil reported in the literature is 8 milligrams per kilogram of soil. However, it's not that recommended to use our soil test to differentiate if we might have or we might not have sulfur limited for plants. And moreover, if we take our soil sample late in fall and we look at the sulfur we are having in that soil test, that sulfur might or might not be available for the plant late in the spring. It can leach down with the rainfall, or it can evaporate, or it can be fixed. So there are many processes going on that can change those numbers reported in the test. So soil test is not necessarily recommended to predict if we will have or not sulfur deficiency for our crop. Well, so said that, what we went or the objective of this research has been to evaluate and determine how often and how much that corn yield benefit from sulfur applications in Indiana. And the way how we are going to respond to that objective is by having experiments throughout the state of Indiana. If you see this map in the top right, we had experiments at 8 Indiana counties. In total, we have had 28 sites from 2017 to 2020. Most of these locations have been managed under a corn-soybean rotation, and we had locations managed under conventional tillage and to some fields that were not tilled. And the source that we used for sulfur as a sulfur fertilizer was ammonium thiosulfate mixed with liquid urea ammonium nitrate. And we went with rates as low as 7 to as high as 34 kilograms per hectare. And in every replicate, we always include a 0 sulfur as a check or control plot. The field settings of our experiments I am showing here in the bottom left. And in this picture is from one of the fields, again from last year, where we did have a sulfur response, a corn response to the sulfur fertilizer. So we had locations with fields going from 3.5 hectares to 18 hectares. Some of them have 3 to 12 replicates and at least 2 treatments up to 6 treatments. The plot length went from 100 meters and as long as 400 meters, and the plot width it went from 9 to 12 meters. At harvest time, we collected our yield data from the 6 to 8 middle, from the middle of the road within the 6 to 8 meters. So what we did during the growing season, well, starting at planting, we put out our experiments. During 2017 and 18, sulfur was applied at citrus as I started fertilizer at planting. But in 2019 and 2020, we applied sulfur just at citrus. So at citrus time, that was between a B4 to B7 stage. And right before citrus, some of the in-situ measurements that we took was nutrients concentration in the soil, in the tissue. And then after putting out our treatments, we went back at R1 at silking and we measured nutrient concentrations in the earleaf. And at the end of the season, we took samples per plot, ear samples per plot, once again to measure the nutrients in the ear. So, sorry. So for soil and tissue samples, we took the before applying our treatments, we took samples for all the field, one sample per replicate. But once we put out our treatments, the field was sampled per plot. Now let's dig into the results. So here I have this map on the right that I am showing you all the locations where we had experiments. So I have these numbers that represent the response in yield that we had during the previous 3 years, so from 2017 to 2019. I am not including here 2020 because we still need to go out there and get that data. We might be doing that in the coming weeks. So if you want to join us, you are welcome. Well, but okay, so I have here 3 numbers. Every number represents the response for every year, starting with 2017, then the number in the middle, it will be 2018, and the last one, 2019. In the places where you see asterisk is to indicate that we did not have an experiment put out in that year in that specific location. And these zeros stand for the locations where we didn't see any response in yield. So during these past 3 years, we have seen locations having responses, and we had an increase in yield that was as little as 0.2 and as high as 1.3, expressed in megagrams per hectare. As we can see, we have locations where we haven't seen any response, like this one close to the center of Indiana. And there are some other locations where we had responses one year and another year we did not. And so far we have had 2 locations that are kind of in the opposite of each other. One is at the north side of Indiana and the other one at the southeast side of Indiana, where these responses have been consistent and large. Well, these responses in every year and at every location was obtained when with the lowest sulfur rate, and this lowest sulfur rate when as low as 7 to as much as 17 kilograms of sulfur per hectare. So that was sufficient to obtain the maximum yield response. Well, in the early measurements where we took samples, soil samples and whole plant tissue samples, I have the results summarized on this table to the right with the mean for every parameter, every criteria, and the range for each of them. So based on the literature, it has been reported that 2% or less of organic matter in the soil can be an indicator that we might see or we might experience sulfur deficiency, or the plants might experience sulfur deficiency. And as we see here in the range, we have locations with 1% of organic matter that is below that threshold, and other locations with organic matter above that threshold, as much as 3.2% of organic matter. When we look at sulfate sulfur, we have locations below the threshold for sulfate sulfur in the soil. That, as I mentioned in the introduction, that threshold is 8 milligrams per kilogram. So some locations were below the threshold and some others were above. When we look at the sulfur in the tissue before citrus, somewhere between B4 to B7, we have locations once again below the 2.1 threshold that can be considered for sulfur concentration in the tissue, and some other locations that we wouldn't expect to see sulfur deficiency based on what it was already in the plant at B4 to B7. And similar with nitrogen to sulfur ratio, same behavior. However, we did not see any or a good correlation between these numbers and with what we actually saw in yield response. So the locations that were low in organic matter with sulfate sulfur below the critical value, not necessarily yield low as expected. Now, before I start to explain to you about this graph, I want to walk through this equation explaining what does it mean and how did we calculate this. Here I have my results for one of the locations where we had significant responses in yield. So in this field, particular field, we had 5 treatments. And how do we calculate these numbers here for my y-x? My y-axis is we take the yield treatment for that specific, for any of the treatments we are interested on, can be the 0, the 8, 17, 25, or 34 kilograms of sulfur per hectare. We take the mean for that treatment and we divided that by the average of all the treatments that did have sulfur applied. So for this particular one, I am taking my 11.2 milligrams of grain per hectare divided by the addition of the mean for all the treatments that did have sulfur applied. So that is what I use for my y-axis. So now in my x-axis, I have my earleaf nitrogen to sulfur ratio. And the solid symbol represents the locations that we saw a significant increase in yield with sulfur application. Well, you might be wondering why I am showing you just 5 solid figures that represent just 5 locations with significant response. Well, that is because in 2017 and 2018, we did not get grain data and earleaf data for all the locations. But during 2019 and 20, that is the data that I am using for my thesis. We made sure we did get those numbers. So hopefully later on I will be able to show you more complete figure on this parameter. So, well, so far what we concluded from here is that at most locations where we did see an increase in yield, the nitrogen to sulfur ratio was equal or greater than 16. However, as you see, we have some points that are above that threshold, and we wouldn't see a significant increase in yield. So that ratio was a tendency, the 16 or greater than that. However, it was not always the case. Oh, sorry, I forgot. I had this figure bigger for you, and I forgot I had that. Well, so this year we decided to do an sporadic sample to see what is the nitrogen to sulfur ratio in the plants that wouldn't show sulfur deficiency symptoms, and the ones that were showing sulfur deficiency symptoms. So we went out to the field at B7 and at B7 to B11 stage, and we looked for places where we had these different levels of sulfur deficiency symptoms. So this picture on the top right is showing a plant that is healthy, that we wouldn't expect to have a deficiency. And then we have this one in the middle showing a moderate deficiency with a slight yellow striping. And then the one that we label as severe deficiency is smaller, like a pale yellow color and a stronger yellow striping. So what we saw or what we found was that the plant that didn't show deficiency symptoms had a nitrogen to sulfur ratio equal to 18. That is what is reported in the literature to be adequate. Any nitrogen to sulfur ratio equal or less than 18, it's good for the plant. Then in the plants that had moderate and severe symptoms, indeed, this nitrogen to sulfur ratio was higher than the critical value. So we just proved what we expected to see based on these results. And the same similar results were found when we sample at B10 to B11 stage. Now, what happened to sulfur in the grain? So once again, I have here my y-axis that is similar to what I explained before, the way how we calculate it. And the solid symbols represent the locations where we had significant response in yield. And based on this, what we found is that the grain sulfur concentration in these locations that show a significant response had values below 0.8 grams of sulfur per kilogram. In all the rest of locations where we didn't see any significant response in yield, this value was greater than 0.8 grams per kilogram. Once again, I need to state that not all the fields are included in this figure overall for 17 and 18 because we did not collect grain from all the locations. Well, So far what we have seen is that we do see sulfur fertilization, that sulfur fertilizer can increase yield at some locations, at some areas in Indiana. So out of the 21, 10 of them show an increase in yield. And it was necessary, oh, and this yield was achieved just with the lowest sulfur rate that we used for that for those locations. And in terms of the nitrogen to sulfur ratio in the earleaf, in most of the locations that show a response to sulfur fertilizer, we had a nitrogen to sulfur ratio equal or greater than 16:1 in the plots where we did not apply sulfur. And similar to with grain, the grain sulfur concentration at the responsive sites was equal or less than 0.78 grams per kilogram in the check plots. With that, I want to thank to the people and all that people and institutions that have been possible for us to conduct this research. Thanks to the Indiana Corn Marketing Council, to Pioneer and Bex Hybrids, to the Purdue, to all the PACs and the farmers cooperators, to the USDA, National Institute of Food and Agriculture, and of course to the Jim and Bob team members. With that, I will be happy to answer any questions that you might have or any feedback that you could provide. Thank you.
So is there any questions for Deanna? There's one in the chat, Deanna. It's from Javier Gonzalez. It says, how was the soil sulfate extracted?
Oh, we didn't do that process in the lab. We send our samples to A&L. Well, it doesn't matter where we send it, but it was tested in the laboratory and reported to us. Does that answer the question?
Yeah, so Dr. Camberado responded with Malic 3 extraction.
Oh, the method, okay.
Any other questions for Deanna? I have one. How did you determine the level of sulfur that, or I guess how would you determine the level of sulfur that you need at your site? Like if you're a farmer, how could they determine how much sulfur they need to add?
Okay, so for that we use information or what has been reported in other areas in previous research, having similar environments with similar soil type and organic matter. So based on that, we established the rates that we put out in every location. So every location had a different rate.
Okay.
Deanna, this is Bob of the Jim Bob team.
Oh, Sean.
Could you speculate why some of our locations have been inconsistent in their response? Some years good, some years nothing. Can you speculate on why that is at a single site?
Well, I don't know. There are several things that could be playing a role here. Depending how much organic matter we had mineralized that year, that is one guess. That something that I could say, like temperature that we have that year in that specific location. What else? Let me think.
While you're thinking, let me ask this. If you
Yeah.
were a farmer at one of those sites, knowing that once in a while you get a really good response, would you use sulfur every year, knowing also that some years you won't get any response?
Can you repeat that question, please?
So let's say that I'm at one of the sites where we've had inconsistent responses, some years good, some years nothing. If you were a farmer in that site, would you go ahead and use sulfur every year?
If I am not having a consistent response, I might not. I can have, I imagine myself having a control plot. I might not apply to all my farm, but I can keep tracking on that. Having a small plot where I apply consistently sulfur, but the rest of the farm I will leave. If I am not seeing any response, I wouldn't keep applying that every year. But I think it is a good practice to have a small experiment running on your own to check on that.
So I hate to monopolize, but in those sites where we've had good responses, is it fair to say that in most cases we could see the deficiency before we side dressed?
Oh yeah, yeah. At many locations where we didn't see responses, we saw deficiency symptoms early in the season, but at the end, in yield response, we didn't see any difference. So there are many things that could be happening there that we can find sulfur deeper on the profile. So if the roots develop properly, the plant can have access to that sulfur and get recovered, because sulfur is not as mobile as nitrogen, but it's fairly mobile. So later on, the plant can get recovered, and the yield might not have been affected necessarily if the supply gets on time and in the right amount. Does that answer your question?
It's good enough for now.
Okay. Wait till my thesis dissertation. I guess the questions are gonna be harder.
You have another question in the chat, Deanna.
Okay.
I can read it to you. So it's from Adebukula Dada, and she says, do you foresee any problem of increased acidity with sulfur addition, and do you think that may cause a complication with phosphate in the soil? And how would you make sure that that doesn't happen?
Oh, well, I think the amounts of sulfur that we are using wouldn't affect the pH as much. There is an experiment done in, I think it's in Oregon, when they applied around, they went crazy with the rate. I don't remember it. I think it was around 100 to 300 pounds of sulfur per acre, which is quite a lot. And they did see a change by 0.3 units, if I am not wrong, in the pH in long term. But with the lowest rates that are as low as the ones that we are using, the pH was not affected, I would say, at all. It remained the same. So I will say in the amount that we are using, it wouldn't affect the pH. It's not expected that to happen. So I think I didn't mention in the introduction about we had the situation in one of the farms that we didn't see any response of sulfur application, and then it happened that early in the season there was phosphorus applied, but this phosphorus was applied with some traces of sulfur, so that sulfur also reached the control plots. So that can also be something that we need to consider when we are doing an experiment. Make sure that the control plot didn't receive sulfur even from previous applications. So in that case, we wouldn't see a response and we will think, oh, sulfur is not getting, corn is not getting any benefit from the treatment that we are applying, but it was because sulfur was applying to the control plots before we put our treatment.
Okay. Any other questions for Deanna?
I think here is a question. Do you think that the protein quality quantity might change if there is soil sulfur deficiency? I haven't seen that reported in corn since it doesn't have as much protein, but I know that I have learned that from the, I think, soy crew team, that the protein in soybean is affected when sulfur is not enough. As I mentioned in the introduction, it is necessary to have a good ratio nitrogen sulfur because both occur in protein and they occur in an invariant proportion. If you don't have enough sulfur, doesn't matter if you have good amount of nitrogen for the plant, the formation or production of the protein is going to be threatened or compromised. I hope that answered the question of Javier Gonzalez.
Okay.
Okay.
Anybody else? Okay. Hearing no other questions, I think that we should all give Deanna, I guess, a virtual round of applause. I just thank you, Deanna, for sharing today. Before we leave, I just want to again remind everybody of the workshop on the 21st. And if you do plan to attend, registration is required by the 19th. So, and the registration link was in the email that, or in the calendar invite that was sent out. So again, thank you, Deanna, and everybody have a nice weekend.
Thank you.
Thank you. Good weekend.
You too.
Thank you.
Nicely done, Deanna.